Good afternoon, everyone. Sorry that I can't be there with you today, but hopefully with this video it feels like I'm there a little bit. For questions from the homework, obviously I don't know which are the questions that you would have had, so I decided that I'm just going to take out two of the questions and hopefully they'll help kind of review the dividing polynomials that we did on Friday. So the first one that I'm going to look at is number 3 and part E. That one asks us to divide the 3x plus 2 is our division part, and we're dividing it by 6x cubed plus x squared plus 7x plus 3. Now, one thing about this question, and it's part of the reason that I chose it, is that they don't give this part here in order from the highest degree to the lowest degree. They mix it up, but you always have to put it in that order from lowest degree to highest degree to be able to do this division. So we had to rearrange that. So now remember, when we're dividing out, we always look at what do we need to multiply by our first term here to get the term that we're looking at underneath our little division sign here. So what do we need to multiply 3x by to get 6x cubed? And that's 2x squared. So remember, we multiply that out and put it down at the bottom here to get a 6x cubed. And then we carry down the next term as the top term multiplied by the second term in our division here. So 2 times 2x squared. So we have a 4x squared here. Remember that we always minus these out. So we know that those cancel each other out. And then x squared minus a positive 4x squared gives us a negative 3x squared. And then remember, we carry down the next number, which in this case is the 7x. Sorry about that. Here we go. Then we do that again. What do we need to multiply to our 3x to get a negative 3x squared? And that should be a minus x. Multiply that out by each piece, so minus the 3x gives us our minus 3x squared. Multiply the negative x by the 2, so we have a negative 2x. Subtract them out, so that we're left with a 9x. And then carry down our number here, so we have a plus 3. And then again, what do we need to multiply by 3x to get a 9x? And that should just be a plus 3. Multiply out our 3 by our 2, so we have a plus 6. Subtract those out, and we have our negative 3 remainder. So we know that when we divide this polynomial by 3x plus 2, our answer is 2x squared minus x plus 3. The other question that I'm going to look at is number 4, and it's going to be part B. In number 4, you're given an already factored piece. And they ask you to figure out what the remainder needs to be for this to be a true statement. patient here while I'm typing this out. Okay, so hopefully the first thing that you see that we need to do on this side is we need to expand out all our brackets so it looks like it's in this expanded form here. So remember, when we expand out brackets like this, we take everything that's in the first term and multiply it by everything in the second term. And we're going to do the same with the second number and multiply it by every single thing in the second bracket. So when we expand that out, we have an x cubed minus a 3x squared plus a 4x plus a 2x squared minus 6x plus 8, and then still plus that remainder that we're trying to figure out. So let's simplify, putting the like terms together. So we have a negative 3x squared here and a 2x squared that we can put together. And we have this 4x here and this negative 6x that we can put together. So instead of a negative 3x and a plus 2x squared, we're now just going to have a minus x squared. And to put our 4x and our 6x together, we're going to be left with a negative 2x. And then we still have our plus 8 and our plus remainder. Now let's look at the answer that we're trying to get it to look like. We're trying to get it to look like this. So far it's looking good. We have the x cubed, the minus x squared, and the minus 2x. The only thing we need left is this minus 1 piece here. So we need to look at the number, the plus 8, and our plus remainder to decide what that remainder needs to be for that to work out to be a minus 1. And hopefully you see that a plus 8, if we do a remainder of a minus 9, then in the end, we have our minus 1, which is what we need. So our final answer here looks like the answer that it wanted us to. So that means that our remainder had to be a minus 9 for this statement to be true. Hopefully, if you had any questions from the homework, that covered some of them. If not, remember, you can always ask some of the other math teachers to explain it for you since I'm not there, or you can wait till I come back and you can ask me at that point in time. What we're going to look at today is, instead of dividing using long division, which you still need to know how to do, we're going to look at a method that's a little bit faster than the long division method. And what it's called synthetic division. So it's still a method for dividing polynomials, but it avoids that really long notation that is the long division. And it's called synthetic division. But it requires a divisor that has a binomial form. And what that means is that there's no number in front of that x. So if we look back at this example here in E, this wouldn't work for synthetic division because it has this 3 in front of that x. For it to be binomial form, it has to just be an x by itself without a number in front of it. So I'll give you a second to write this down, and then we'll look at an example. So our example number 1, it asks us to divide this polynomial by x minus 2, and this time we're going to use synthetic division. So what we do with synthetic division is we need to list what our k value is, and that's whatever the coefficient of, the number is with our binomial here. So we're just going to make a little note here. So we list the k, which in this case is 2. And that's because this is a 2 here, and when it's a minus, it's going to be the opposite. So in this case, our k value is going to be a positive 2 because in the factor, it's a negative 2, just like when we're looking at roots. And we also look at the coefficients of the polynomial, and we list them in a row. Then we're going to bring down the first coefficient, which in this case is a 4. Then we're going to multiply it by the k value, which again is a 2, and add it to the next coefficient. So that equals a negative, or sorry, which is a negative 5. Then we're going to continue this chain until the end. Now that in that description you might be a little confused, but we're going to do the example with this. But I just want to make sure we had that down in our notes, because those are the steps that we're going to follow. So we're going to start off by listing our k value, which is our value of 2. So that's where we start off here with that value of 2. And we're going to draw this little box here, that's kind of our division line here. Then in the same line with that 2, we're going to list the coefficients of our polynomial. So we're looking at our polynomial up here, and we're just writing the coefficients. Remember, the coefficients are just the numbers in front of our variables. So we're going to list them out. We're going to start with the 4, then the negative 5, then the 3, and then the negative 7. So just list them out in a row here. Then, just as it said, we're going to carry down, bring down the first coefficient, so that's this 4. We're going to bring it down to the bottom here, so that our first answer here starts with a 4. So we automatically carry that down. Then what we do, looking at our steps, our next step is to multiply that value by k. So what we do is we take this number here and we multiply it by k, and it goes up here. So this step here is we're multiplying by our k value, which is 2. So we're timesing it by 2 to get this new value that's up here. So we're doing 2 times 4, which gives us a value of 8. Then what we do is in this row here, sorry, this column here, is we're now going to add these coefficients together. So we're going to take this negative 5, and we're going to add it to the 8 to get our next number down here in our answer. So negative 5 plus 8 leaves us with a positive 3. And we're just adding those together to get this next number. And then we just keep following those steps. We're taking this number, we're multiplying it by the k value. So we're multiplying it by 2. So we're doing 2 times by this 3. Gives us this next number here. So 2 times 3 is 6. And again, we're adding those two numbers together in this column. So 3 plus 6 gives us our next number and our answer at the bottom, which in this case is 9. And we need to do that once more. So again, we're taking this 9 and we're multiplying it by that k value, which is 2. To get our next number here. So 9 times 2 gives us 18. And again, we're adding this column. So negative 7 plus our 18 gives us our final value at the bottom, which is actually going to be our remainder here. So negative 7 plus 18 gives us 11. So then what we're looking at here is these numbers here that are listed at the bottom, the first numbers here, those are the coefficients of our answer. Which is called the quotient. So again, that's a little new terminology. Our answer is called the quotient. So coefficients of the quotient. And then always the last number of this piece here, whatever that last number is, that is always our remainder. So then our answer here would be therefore our polynomial that we started off with is equal to the factor that we were dividing by, which was x minus 2, times by our new answer, so 4x. Now this one gets whatever the second value was, so because this was a cubed, this means that this 4 has to be a squared. So it's going to be 4x squared plus 3x plus 9, and then we have a remainder of plus 11 at the end. And I'm not writing this in quotient form, I'm just going to leave it as plus 11. So hopefully you understood most of those steps. We are going to go through a few more examples to hopefully get that set in. If anyone still needs to write this down, just make sure you pause the video for those who still need to keep writing. So example number 2 here. We're asked to divide this polynomial by x plus 2 using synthetic division. So notice that this polynomial here isn't in order in terms of the highest polynomial first and the lowest degreed polynomial at the end. So we're going to have to first rearrange the terms into standard form, which is the highest degree first. And then remember, we also have to account for those missing powers if there are any, which in this case there are. We're missing the x squared. So now this sorry about that. There we go. Just adding in that 0x squared and rearranging it around. There we go. So now it's in order for standard forms. We have highest power first, lowest power, and we added in that 0x squared so that we have all those missing powers. So again, remember we start off by writing our k value, which in this case, because we have x plus 2, this time our k value is always the opposite sign, so this time it's a negative 2. Again, we're going to draw our little division box. And then on the same row of that negative 2, we need to write all our coefficients of our polynomial here, and it has to be the one that's in the proper order in the standard form. So we have that 1 in front of that x to the power 4, Then we have a negative 2 in front of that x cubed. Then 0 in front of that x squared. 13 in front of the x, and then a 6 at the end. So then again, remember we start by carrying down our first coefficient into our answer. So know that we start off with a 1. Then we multiply our k here by this number. So negative 2 times by 1 gives us negative 2. And remember we add our column. So we have negative 2 plus a negative 2. So we have a negative 4 down at the bottom. And again, we need to multiply this number by our k. So negative 2 times by negative 4 gives us a positive 8. Again, we're adding our columns. So we have 0 plus 8, so we're left just this 8. And negative 2 times our 8 gives us negative 16. Adding our row, 13 plus our negative 16 gives us a negative 3. And then our last one here, negative 2 times the negative 3 gives us a positive 6. Again, we add our row to get a 12 as our remainder. Okay, so then again, our final answer is all these numbers here, with our remainder always being the last value. So we know that our answer is x plus 2. It's the factor that we were dividing by. And then again, you just follow these down. We started with an x to the power of 4, so we know our answer is always going to start off with 1 degree less. So we have 1 here, so it's going to be 1x cubed. Minus a 4x squared. Plus an 8x and minus a 3. And then we still have our plus 12 remainder at the end. And again, I'm just leaving that as a plus 12 because I'm not putting it in quotient form. So there's our final answer for that division. Hopefully that helps you understand a little bit more the steps that goes along with synthetic division. There is one more example that I want to look at. Now this example is in the case where we have to deal with a number in front of that coefficient in front of that, or our coefficient in front of our x there. So again, we're dividing this polynomial by this factor of 3x plus 2. So again, because this is a special case, we're going to start off with a little note about this. So 3x plus 2 we know is not in the form that we need, which is x minus a k. However, we can rearrange it so that we can still use synthetic division. It just makes it a little bit more difficult. So we can rewrite 3x plus 2 as if we factor out of a 3 out of both of these terms, So we factor out a 3 out of the first term, so we're just left with an x. But if we try and factor out a 3 out of this 2, it leaves us with a fraction, and that's exactly what we're going to have. Is now instead of a 2, we're going to have 2 divided by 3 as our k value. So when we do that, it gives us the right form. But what we have to worry about is that phantom 3, and we'll have to deal with that at the end. And that's the 3 that's outside of these brackets here that we factored out. So we have to remember that we factored out that 3 and deal with it when we're writing our final answer. But first, we're going to proceed with our synthetic division and deal with that phantom 3 at the end. So again, with synthetic division, we always pull out our k value. It goes out front. So in this case, we're looking at the factored form here that we did. So our k value is this 2 over 3. Because it's a plus inside those brackets, it has to be a negative 2 over 3 when we pull it out of the brackets. We can draw our little division box. Remember, the first row is the coefficients of what we're dividing. So we have 12 from the x cubed, 2 from the x squared, 11 from the x, and a 16 at the end. So I'm going to not put arrows on it this time, but we're going to carry down the 12 to start off with. And we need to multiply the 12 by this negative 2 over 3. Remember, when you're multiplying fractions, negative 2 over 3 times by 12. We can think of that as 2 times 12 is 24, and then divide by the 3, which is, in this case, a negative 8. Or you can think of it as 12 divided by 3 is 4, and then we have 4 times the negative 2, which gives us the negative 8. But either way, that negative 8, remember, goes in the next column. We add that up, 2 plus a negative 8, which leaves us with a negative 6. And we multiply the negative 2 over 3 by the negative 6, which gives us a value of 4. Again, we're going to add up our column here. 11 plus 4 gives us 15. Multiply that 15 by the negative 2 over 3, which leaves us with a negative 10. Adding up our column, 16 plus a negative 10 gives us a positive 6 for our remainder. So again, the first numbers are always our answer. The last number is our remainder. But now we have to go back and deal with that phantom 3 that we talked about before we look at our final answer. So what this means is our quotient, which remember is that final answer that we're getting. That's what the final answer is called, as a quotient. It has been what's called inflated because we factored out that 3. So it's been inflated by the factor of 3. And this is the 3 we removed earlier. So what we do is we need to divide each coefficient by that factor of 3 to account for this. The only thing that we don't do is we don't do it to the remainder. We don't need to divide out that 3 from the remainder. So if we take our answer here, we're going to divide each of these by 3. So 12 divided by 3 is going to give us a 4. This -6 divided by 3 is going to leave us with a -2. Our 15 divided by 3 is going to leave us with a 5. And then remember, we don't divide our remainder. It stays the same, which is just the 6. So then we can write our final answer here. So we have that 3x plus 2, which was our original factor that we were dividing by. We're left with 4, and again it's an x squared because our original polynomial started with an x cubed. Minus 2x plus a 5, and then we still have a remainder of 6 here. So then this gives us our final answer. So this is then the case of what you have to do if you want to use synthetic division when there is that number in front of the x in our factor that we want to use. So that's it for examples. I want you to use synthetic division to solve. It may not say in your textbook with these questions to use synthetic division, but that's what I want you to practice with, because you should be able to use both long division and synthetic division in this course. I can ask you for either of them, and I can specify which one I want you to use in certain questions. So please make sure you're practicing synthetic division on these homework questions. Whatever time is left in class, you have that time to work on these, so I suggest you use it wisely. Other than that, I hope you have a great day, and I'll see you later.